Scholars, good afternoon. The purpose of this video is to talk a little bit more about transformation of functions, specifically translations or shift, the same thing. Mathematically speaking, translation, you're translating, you're moving the function throughout the plane, the XY plane. Of course, we know how this graph looks like. However, let's say that we don't know. So let's go ahead and plug in, let's go ahead and evaluate the function, namely plug in numbers. So see what's the output. Okay. Let me start in the middle. When x equals 0, of course, 0 squared will be 0. When x equals 1, this one will be equal to 0, of course. When x equals 1, 1 squared will be 1, 2 squared will be 2, 2 squared will be 4. So 1, 4, 3 squared, of course, will be 9. When we're in the negative world, negative 1 squared, of course, this is 1 as well. Negative 2 will be 4, negative 3 will be 9. So if we attempt to graph this function, this is what we get. And I thought I was ready for you folks. This is what we have. This, of course, is what we call the parabola. So the graph will look like this: 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, oops, negative 2, 4, negative 3, 9 as well. So you would take the parabola. Okay? If we were to read the behavior of the, to read what's going on, of course, the domain is all real numbers. The graph is defined from negative infinity to infinity. In other words, we can square any number. However, the output or the range, notice that the square is never negative because the 2, of course, is even. So we go from 0 inclusive all the way to positive infinity. So, of course, back to basics. The x represents obviously the domain or the input. The y represents f of x, which is, of course, the range of the function or the output. Woohoo, no big deal. Now, what happens if I have the following, folks? What happens if I have f of x equals x squared plus 4? We'll attempt to build the same table. X, 0, negative 1, negative 2, negative 3. And then 1, 2, 3. And then we're going to add 4. So I would like to know what type of effect this plus 4 does to the function. So we have 0, negative 1, negative 2, negative 3, 1, 2, 3. Okay. So what do we have here? When the input comes in, we square the input and then we proceed to add 4. So when x equals 0, the output 0, right? This is the f of x, this is the output. We add 4, so this guy will be, of course, 4. When x equals 1, we square and then we add 4. So 1 square will be, of course, 1. Plus 4, 5. So 4 plus 5 would be 4 plus 4 would be 8. 9, which is the original output here when x equals 3, plus 4 would be 13. And of course, here will be the same thing. When the input is negative 1, that will be negative 1 squared plus 4, but the output is 1 plus 4. 5, this guy will be 8, and this guy will be 13. So if I were to graph these points, you will notice that it's going to be exactly this graph where all the output numbers are being pushed up 4 units. Okay? So I'm going to erase the numbers. Hopefully you notice that. So, and then I'm going to do something very similar. So I'm going to graph here f of x equals x squared plus 4. And you will notice that some out of range here. this guy was, before it was 0, 0. Now we're here at 4, and then we have the same behavior of the graph. And I just feel bad I erased the numbers. Anyway, it's supposed to be the same tail. It's symmetric, so well, now it's even worse. Okay, anyways, what if I have the following, folks? What if I have f of x equals parenthesis x plus 4 squared? When we attempt to build the table, I'm going to build it completely. So I have 0, -1, -2, 1, and 2. So what do I have here? This is going to be equal to parentheses plus 4 squared. Notice that when the 0 comes in as input, what do? We add 0 to the x to the 4, and then we square. So this 4 squared will be, of course, this case will be 16. Just keep on when x equals 2. So when the 2 comes in, now we add 4, which is 6, and then we square, so that guy will be 36. Okay. So even though we're adding the same number, we have, to what ideally I erased the numbers, we have different behaviors. Let's see if we can summarize what's the behavior. Okay. If I have f of x equals x squared plus 4 versus f of x equals x plus 4 squared. Notice that, of course, f of x is your output, the x is your input, the domain, your range. So when I'm adding 4, I need to ask myself, am I adding 4 before or after, in this case, I square? In the first case, first I need to square. So to the output that is a square, that's what the function does, it squares things. So after we square, then we add 4. That means that this 4 is affecting the output. We are adding 4. Here in this case, we are affecting output. We are adding 4 after we square. On the contrary, here in this case, I'm adding 4 to the x and then I square. When x equals 1, for example, 1 plus 4, then I square. When x equals 1, 1 square, and then I add 4. So in this case, I'm adding x before, I'm adding 4 to x before I take the squares. In this case, the adding of the number affects input. And of course, I know that my output is the y, my input is the x. So what do I have? This is borderline my point. Let me see if I can erase this now. So if I have the following, if I have f of x plus a number c, or f of x minus a number c, these two are affecting the output. I'm adding c after I do blank, in this case, the square. It could be the square root, it could be the cube root, whatever function is. First we execute the function, then we either add or subtract a number. So these are going to be vertical shift. Of course, we are affecting the output, the vertical, we're going either up or down, because I'm adding or subtracting the number after I execute the function. These are my vertical shift. We move them up or down. Versus the other case that I have, if I have the following, if I have f of x plus c versus f of x minus c, I'm adding a number or subtracting the number to the x. And of course, we know that the x is the horizontal. It's going to be horizontal shift. So I'm adding or subtracting a number before I blank. Either square, square root, take the absolute value, take the reciprocal, whatever function we're doing, If I add or subtract a number in X, that's horizontal shift. If I add or subtract a number, see a constant, after I take care of the function, then this is going to be a vertical shift. Now, maybe this is kind of obvious, hopefully, or maybe not. If I add C vertical, see that means that the graph moves. This represents move the graph or the function move C units up. We add, we push it up. In this case, of course, we push the graph down. So this one represents C. I don't even know what I wrote the word of most. Just ignore the word. So this guy is C unit up. This guy, of course, will be C units down. Horizontal shift, of course, we're going to go east or west. If I, careful here, folks, if I add C units in X, you probably use out the where are we going? Maybe we move to the right. No, we move to the other right. This will be C units left. If I add, we push left. If I subtract, we push right. C units right. So be careful with these two. They don't kind of counterintuitive. If I add, we expect to go to the right, no, we go to the left. If I subtract, no, we go to the, no, we go to the right. Okay, so that's how we go these translations / shift. Thus, if I had a function f of x equals x squared minus 3, well, I'm subtracting 3 after I square, so I'm affecting the output because I do it after. That means that it's going to be the parabola, push 3 units down. So we don't start at 0, 0. Where do we start? Now we start here at -3, and we go up. And give or take. Okay, so now by the way, in the parabola, in the quadratic function, the domain is always of real numbers. So no questions asked. It doesn't matter what we do with the poor thing, the domain is always of real numbers. But now the range before it was from 0 to infinity, now it's going to be from -3 to infinity. -infinity, the domain, and the range from -3 to infinity. Okay. Let me erase the summary here. So what if I have the following, folks? What if I have f of x equals x cube, parenthesis x minus 1 squared. So I'm subtracting 1 in x and then I square. Let me just use -3 so you see the difference between the two of them. So x minus 3 squared versus x squared minus 3. This is going to be a horizontal shift. Since I'm subtracting, we go to the right. When we subtract inside, we go to the right. In this case, we subtract outside, we go down. So what do I have? Big deal. My function now pushes, it was at 0, 0, we push it 3 units this way. So this is what I'm going to do here. This is going to be 3. I'm going to put a dotted line. It will be easier for me to graph. And then going through 3, of course, x equals 3. And then now my graph, my translated graph, it looks like this. Opa. Give or take. Okay. Let me give you another example. What if I have f of x equals x plus 2 squared plus 4? Now we have both. So what do I have? Since I'm adding 2 inside, I'm affecting the X. Therefore, this is a horizontal something. Either we go to the left or to the right. Since I'm adding 2, we go left. After I square to that result of the square action, we go 4 up. So what does this 4 represent? It represents a shift up. Then after that, first I add 2, then I square. So this is horizontal. After I square, I add 4. Think of PEMDAS. So now we go up. So this one has both things. So what do I have? We have, what do we have? What do we have? Mess. So we push 2 units to the left. So let me just do this dotted line here. And this is -2. And we push 4 units up. This is not obviously at scale. So from here to here 2, and then from here to here 4. That's black. So this is 4. So notice that I have now a new quote unquote plane. So now I can place my parabola here. The coordinates of this point will be -2, 4. Coordinates will be -2, 4. And that's your vertex, as we'll talk about the vertex in a few. So that's the vertex, -2, 4. 2 to the left, 4 up. Domain or real numbers, they range from -2 to infinity. Okay. Let's place one the other way. Let's do one more example. What if I have f of x equals parenthesis x minus 5 squared minus 1. Hopefully you guessed this. If I'm subtracting 5 before I square, so since I subtract, we don't go to the left, we go to the right. And since I subtract 1 after I square, I'm affecting the output, so this probably pushes the graph down. I like to do the dotted line here at x equals 5. And x equals what? Y equals -1. And of course, the parabola would be here. Coordinates, vertex, 5, -1. And too bad I erased the other example. Let's assume that this graph, this function represents $1 million. X years, million, this is revenue $1 million, X years after the year 2000. So what does it represent? That in year 5, so this is X years after 2000, in year 5, namely in 2005, this company reported -1 million of revenue, so they lost money. Okay, so in year 5, which is X, this represents X years after 2000. It's written poorly, and then the Y represents revenue. In what? In $1 million. So in year 5, the company reported -$1 million. So that -$1 million is the minimum, not that this is the lowest value, -1. From this point forward, the revenue is higher. So remember, the Y is the actual output of the function. The X is when it happened. So in my stupid example, the company reached -$1 million in year 5. Okay, so that's the 5, -1 represent if we have the story. So that's what it is, shifting. Notice that we know that the graph is going to move if we are adding or subtracting. If I add or subtract a number to the function, it's going to be moved around the plane. Okay, so if we add or subtract, we either go up, down, left, or right. And that would be it. Let's review other type of transformations for functions. Number one is translations or shift. That's when we add or subtract a number to the function. And we need to identify if we add before we perform the function or after. That will determine if we move horizontally, if I affect the X, or vertically, if I affect the Y or the output. Now let's talk about reflections. Reflection, if you multiply by -1, we are going to flip the graph. You're going to reflect the graph. We have two choices. We either multiply by -1, this is what this negative means, after we execute the function, or I multiply by -1 to the X, and then I do the function. Okay, so in the first case, since I'm going to multiply by -1 after I do blank, square, square root, cube root, etc. So this guy, this -1, I'm going to put it in quote because this is not proper English or math. So this -1 affects the output. Okay, so the -1 is outside, so it's affecting the output. And of course, we know that the output is Y. Yeah, if it affects the output, what we're going to reflect. This will be an X-axis reflection. If the negative is inside, quote unquote inside, that negative is affecting the input. This guy affects the input. And the input, of course, is X, right? Since it's affecting X, we do a Y-axis reflection, so it's the opposite. If the negative affects the X, it reflects in Y. If the negative affects the Y, reflects in X. So here that would be Y-axis reflection. But there are not that many examples of this one. Especially for the function with the quadratic, that we don't even talk about this one in the quadratic. You see why? So we have two examples. So I have f of x equals x squared. That's my basic function. That's my core. This is one where I start. So I have two choices. I can multiply by -1, quote unquote, inside, so it affects the input, or outside, affecting the output. Let's do the outside first. So I have f of x equals opposite of x squared. Remember, order of operation, we first need to square, and then we multiply by -1. Exponents always go first. So first we square, we raise to the 2, and then we multiply by -1. Since it's affecting the input, correct? Sorry, negative, so it's affecting the output because we multiply -1 after we square. So it's affecting the output, it's affecting the Y, so we need to reflect in terms of X. So literal reflect means flipping the graph. We're going to reflect like this. Whatever is on top goes to the bottom, what is in the bottom goes to the top. So now instead of having a quote unquote U facing up, we're going to have a U facing down. We flip this way. So now my new graph will be like that. Okay. So remember, the domain is all real numbers for both. The range here is from 0 to infinity. So the range will be from 0 to infinity. So domain, infinity to infinity, the range bracket 0, infinity. Here still the range, this domain is the same. We have infinity over to infinity. However, the range got flipped. So now we always go from bottoms up. So we'll go from negative infinity all the way to 0. So parentheses, always parentheses for infinity, negative infinity, comma, 0. Domain and range. From 0 to infinity, negative infinity to 0. And the other example, which makes no sense, will be f of x equals parentheses negative x squared. See, huge difference. The negative goes outside in this first case. So first I square, then I take the negative, the opposite. Here, since I had the parentheses, I must take the opposite of x, so I need to affect the x, and then I square. So first I do magic with x, and then I square. First I square, and then I do some magic with the y. So in this first example, square, and then the negative, and then the square. So I'm affecting the input here. Since this affects the input, namely the x, we need to do a y-axis reflection. And again, this one is the one that makes no sense. So now we need to flip the graph like this. So whatever tail we have on the left, it goes to the right. Whatever tail I have to the right, it goes to the left. So from quadrant 2 goes to quadrant 1 goes to quadrant 2. But guess what? We end up with the same graph, which makes sense. Because if you know negative x times negative x, algebraically speaking, that's x squared. So we go back to the original problem. So anyway, so there you have it, folks. The first thing we did was transformations, very simple with the parabola. If we add or subtract, whether move up or down, left or right. If I multiply by -1, we need to identify where are we multiplying that -1, affecting the input before I square or after I square. If it's after I square, I'm affecting the output, it's an x-axis reflection. With the parabola, you won't see this input, you end up with the same thing. So let's go ahead and do 2 examples, or 3. What if I have the following, folks? F of x equals minus parentheses x plus 3 squared. Then what if I have f of x equals minus x squared plus 3? Of course, here I'm adding 3 inside, so we better move to the left. Yeah, so we'll be here at x equals -3. But this negative is outside, it's affecting the output, so we have to flip or reflect in terms of the, it's affecting the output, so we reflect in terms of the x. So the inner parabola is opening upward, so now we'll be facing down. Remember, the domain stays the same, the range changes from -infinity to 0. This guy, minus x squared plus 3. So the minus is outside, so we better flip it, and then we push it 3 units up. So the graph would be like that. Okay, so flipped, just like that, and then we push up. One more example, so we can wrap it up. Because I'm adding to inside the x, this is the horizontal. I'm adding, so we go left. I'm subtracting 2 after I square, so we push down. And the lovely negative is outside, so it has to be a reflection. However, the reflection is going to be, since it's affecting the output, the reflection will be the x-axis reflection. Yes, I believe we have the graph now. We can picture it. We push 2 units to the left. We push 2 units down, so the vertex is right there. But it's not going to be opening up because since we flip it, it's going to be opening down. Coordinates will be -2, -2, coordinates of the vertex. So this one, notice that it will have a maximum because the highest value is -2. Everything else below the -2. So you will notice very soon, if you didn't notice now, that if the parabola opens up, the vertex represents the minimum. If the parabola opens down, the vertex represents the maximum. And when do we know that the parabola opens up or down? I want for you to think strategically. We have this lovely negative in the front, and there is an invisible A here. So if A, my lead coefficient, is positive, the parabola opens up. If A, the lead coefficient, is negative, parabola will be opening down, so the vertex will be there. In this case, the vertex is the minimum. If it opens up, this is the lowest value. If it opens down, this guy here will be the max, the highest value. Okay, so there you have it, transformation of functions. With only 2 things, I'm going to skip the other one. So we already know if f of x equals a parenthesis x minus h squared plus k. And so let me assume here, sorry, what sign? Let's just assume the a is 1 for now. It's an invisible one here. Or if I have f of x equals minus parentheses, just call this guy g of x. G of x equals parenthesis 1 here, minus x minus h squared plus k. So what happens with f of x? 1 doesn't do anything, so it goes h units to the, so that h is positive. H should in this case, so this will be x equals h. We move it h in this way. And let's assume that k is positive, so k units up. So my translated graph would be here. That would be that one, will be f of x. Now g of x, okay, so same thing, we push it to the right. And k, but now it has that annoying negative. Should just be negative. So we push it this way. Vertex is still the same number. However, because of the negative, what we did, well, we actually reflected it this way. So now it's a parabola opening down. So we can see the domain and range. Okay. So notice, let's just stop here. So hopefully we'll be able to see this before the next class, and we'll go from there. Thank you.